All right, geometry. Hey, we're recording a video today. I'm sorry I couldn't be there. Um, I'm on some medicine right now that makes me drowsy and I can't drive. But my goal is I will hopefully be there on Tuesday. So I apologize um, for that. I'm sorry, especially with state tests coming up. But we are still talking about volume. So we talked about volume of prisms and cylinders last week. Make sure you have your state test reference sheet out to help you go along with this. Today we're talking about pyramids and cones. And there's a pretty cool property that is affected with all conical or pyramid-like shapes. So anytime we have a shape that is tapered off to a singular point from a base, that makes this pyramid pattern or a conical pattern, or any sort of, and the pyramid doesn't necessarily have to be a square base. It can be any sort of base that tapers off to a singular point from those vertices. There's a unique property that all of these have with their volume. So before, we remember the volume of a prism. The volume of a prism was equal to its base times the height. And that was for any prism. As long as we knew what the base was, we could find the area of the base times the height. Well, a unique feature about any pyramid is if I take a prism and I were to close one base into just a singular point, it always results in a single 1/3 of that volume. So the volume of any pyramid or cone will always be 1/3 the area of the base times the height. So really all we're doing is the exact same strategies we were doing last week when we were solving for the volume of prisms. The only thing we're doing differently this week is that 1/3. We just have to take whatever we get and multiply it by 1/3, or add 1/3 into our formula when we type it into our calculator, and we will have the volume of a pyramid. So let's take an example. Let's look at this example here. So we have this 16 by 16 square base pyramid with a height of 6. And once again, when we're talking about vertical height, we're always talking about, or when we're talking about the height of these shapes, we're always talking about the vertical height from the base to that very top point. And we're not talking about along the side. I don't need that slant height along the edge of my shape. I want from the center of my base directly to the top. What is that height? In this case, they told us it's 6 feet. So like in this, they give us a little bit of extra information on that second picture over there. But starting out this one, we know first thing we want to figure out is what is the area of the base. So we know that it's a square base. So I'm just going to do side length times side length, or side length squared. So I can do 16 times 16, and that gives us 256 is the area of our base. And then plugging our information into our formula, our volume is going to equal 1/3 times 256 times our height, which is just 6. So typing that all into our calculator, we get 1/3 times 256 times 6, and we should get 512 feet. And then once again, because we are dealing with units of volume, this is going to be feet cubed. So 512 feet cubed. Pretty simple, right? It's just pretty much the exact same thing we were doing last week, except adding in that 1/3 in there. Same idea with that second one, right? It's still a square base. So our base area is just our side length times side length. So 6 times 6 for the area of my square base, which is 36. And then my volume, once again, is equal to 1/3 times 36 times my vertical height, which vertical height from the center going up is 4. So that vertical height of 4, typing that whole thing in the calculator, 1/3 times 36 times 4 gives us a volume of 48 meters cubed. 48 meters cubed. Pretty simple, right? Not too bad. Skipping around a little bit, this might not be in the exact same order as what shows up on your paper, so I apologize for that. But we're going to jump to some of these hexagonal and pentagonal pyramids. So these are pyramids still. They still have a base on one side, and all those vertices taper off into a point at the top. But my base is no longer that square base pyramid. Now I have this, let's see, 1, 2, 3, 4, 5, 6. This is this hexagonal shaped base. So we're still going to do that formula. We're still going to do our volume formula. Volume equals 1/3 times the area of my base times the height. So once again, we have to think, okay, 1/3 times the area of the base times the height. So first thing I want to come up with is that area of the base. Well, because this is that hexagonal base, thinking back to what we had to do last week when we encountered a hexagonal or pentagonal prism, we had to split it up into shapes that we can recognize. Well, because I don't have an area formula for just this, we could split up into those triangles. So pulling up my little drawing tool here, if I slice this up into a triangle, I can find the area of that triangle. Oh, that's a perfect line right there. Let's try our line tool instead. Trying to find the area of this triangle can make this a little bit easier for us. So splitting this up into those multiple different triangles, we can then multiply by the number of triangles we have, and that will help us get that area of our base. Lovely picture, Mr. Jarvis, you're an artist. Okay, so thinking about this, we have 1, 2, 3, 4, 5, 6 total triangles. So the area of our base, we know we're going to have to eventually multiply by 6 because I'm going to have 6 total triangles. And all those triangles are going to be the same. They all have a base length of 10 because each of these sides are going to be 10. And they all have a height on each of those triangles of 8.66. So if we think about the formula for area of a triangle, if we look at our reference sheet, it's 1/2 times the base of 10 times the height of that triangle, which is from the bottom to the top of my triangle, 8.66. So 8.66. So typing this in for our area formula, we have 6, because there's 6 total triangles, times the formula of the area of a triangle, 1/2 times 10, my base, times my height of 8.66, and that gives me 259.8. And once again, that is the area of my entire base, 259.8. So once we get the area of that base, we are going to have to put that into our volume formula. Volume formula, once again, 1/3 base, which is 259.8, times height, which is, looking at our vertical height, now that we look at this, we got an issue. If I get rid of some of these lines, it might clear it up a little bit for us to see. Now, looking at this picture, they gave us, in red there, they gave us a vertical height. Let me get rid of all these other red lines so you can see it easier. Sorry about that. Oh, no, go back. Sorry about this. They gave us a vertical height, or they gave us a slant height on the edge of their shape of 14 feet. But I don't want the slant height. I want that vertical height from the top of my pyramid dropping all the way down. I'll do it in green so we can see it a little bit easier. But we would need that vertical height from the top of the pyramid dropping down. Now here's the issue. How am I going to find that vertical height when I only have this slant height? Well, if we think about that slant height, that red 14 feet is going to be the same from anywhere of the top of my shape down to that middle of my line. And if I look at this green dashed line and this red line, they form a right triangle. They form a right triangle from the ground of the base of my pyramid up to the top, along the side of my pyramid, and then down towards the center. That makes a right triangle. And if I know I have a right triangle, I can do Pythagorean theorem. If we draw the little triangle off to the side here for us, that's a star. Where's a triangle? It's not gonna be very accurate in our representation. We might actually rotate it. Okay, if we draw this triangle here, actually give me a brief moment to pause the video. Something just happened. I will be right back. I apologize for that. All right, sorry about that. I had to grab my son for a moment, so he's playing on the ground next to me, so I apologize if you hear anything. But we're trying to find this vertical height. So if we color these sides, our green side is our vertical height that we're looking for. We had that dashed black bottom part. We know that's our 8.66. If we put in 8.66. And then we know our slant height in red here is our 14 feet. Okay, so this is like a 2D image of our 3D pyramid. If we kind of just like slice it down the side, we need to find this green height. Well, if I think about this, because this is right triangle, I have two sides of my right triangle. I can use our good old happy Pythagorean theorem to solve for that missing side. So I'm going to call this side H. and we're going to look for that height. So we know Pythagorean theorem is a squared plus b squared equals c squared, right? So if we do down here, and we know c squared always has to be that hypotenuse, my red side in this case. So I have 8.66 squared, 8.66 squared plus h squared equals 14 squared. So doing a little Pythagorean theorem that we're familiar with in the past, we can square each of those values to figure these out. So 8.66 squared, 8.66 squared is 740, or 74, I'm sorry, not 740, 74.9956, which basically rounds up to, if we round that up, it's 50 knot, or it's like half of a thousandth place away from 75, plus h squared. Let me use the plus h squared equals 14 squared, which should be 196 if I remember correctly. Let me double check that really quick. 196. Okay, so solving for h squared, if we subtract 75 from each side, subtract 75, we get 196 minus 75, leaves us with h squared equaling 121. H squared equals 121, which 121, if we take the square root of both of those, take the square root, I don't have a good square root symbol, so I'm going to do square root of h squared, square root of 121, and we can type that into our calculator, and we get h equaling 11. I'll move that down a little bit so you can see that easier. H equals 11. So sometimes we might have to work a little bit. Sometimes they might not give us all the information. Like if we see on this one here, that would be another Pythagorean theorem. You'd have your a squared, your b squared would be what you're solving for, and then your c squared is that a slant height. So sometimes, depending on the information given to us, we might have to solve a little bit for those h. But now that we know h is 11, we can finally plug this back into our formula, h of 11, and that equals 1/3 times 259.8, which was the area of our base. So this was a big, long problem, times 11 gives us 952. Oh, I'm not typing. 952.6. What's happening here? Oh, that's because my key thing. 952.6, and then that was, once again, feet cubed is our volume. So sometimes it's a little bit tricky. Sometimes we might have to work with it depending on what the shape of our base is, depending on the information that they give us, whether they give us that vertical height or not, or whether we have to solve for that vertical height. Sometimes we might need to do a little extra work. So we're going to do one last example of a cone, and then we will end the video for there. So I believe on your cone, it already has the area formula of the base as a circle. Give me one moment. My son is crawling away. I will be right back. I apologize. Okay, I apologize for the repeated interruptions. Okay, volume of cones. So on your reference sheet on your state test reference sheet, it should also have the volume of cones, which cones are just a pyramid with a circular base. So it's still going to be that same formula. The volume of a cone is going to be 1/3 the area of a base, which we know the base is a circle for any cone. So it's going to be pi, which I don't have a good pi symbol, times the radius squared, because we know pi r squared is our area formula of a circle, times, once again, the vertical height of my cone. So let's just look at this one here. It's nice and easy. Looking at our cone, we have our volume is going to be 1/3 the multiplied by pi, so 3.14. You can use your pi symbol on your calculator, times the radius squared, which my radius from the center of the shape to the outside is 9. Make sure they don't give you the diameter. If they give you the diameter, just divide it by 2. So we have pi squared there. And then times our vertical height, which, looking from the center of my cone to the top of my cone or to the bottom of the cone, depending on how it's oriented, is 12. So typing that whole thing in the calculator, 1/3 times pi times 9 squared, make sure I type it in right, times pi times 9 squared times our vertical height of 12, and we type that in our calculator, and we get 1,017, and we'll do 0.88 centimeters cubed once again because it's volume, and that is our volume of a cone. Hopefully the rest of this hopefully the rest of these notes aren't too bad, and then you can finish those for the rest of the period. I will hopefully see you on Tuesday. I'm really hoping I would be back on Tuesday. I don't want to try to miss any more school because I know that state test is coming up. If you have any questions over this stuff, email me and we can talk. Let me know if you need anything, and